So to find y prime, we need to evaluate the derivative here. So that looks like we're going to need implicit differentiation. We could avoid implicit differentiation if we could rewrite this so that we get y equals something something, but it's quadratic in y. So unless we could factor it, it's just easier to use implicit differentiation. So we're taking the derivative of everything with respect to x. So going term by term, the derivative of x squared with respect to x, that's 2x. We don't need implicit differentiation there because that's the variable for which we're differentiating. Evaluating this derivative, these are two different functions of x. We got 6x and y. We can think of y as some sort of function of x that we just don't know yet. So using the product rule, the derivative of the first function times the second function kept the same, plus the original first function times the derivative of the second function. The derivative of y with respect to x is not something we clearly know, so we're going to write it as y prime. And then here, same thing, we need implicit differentiation. The 2 comes down and multiplies, there's the power rule, but then because of the chain rule, we've got to multiply by y prime. And then the derivative of a constant is 0. Okay, so now the next step is to try to get y prime by itself. So you want to get rid of these terms. So subtract 2x, subtract 6y from both sides. And then we're trying to get y prime by itself. So let's factor out y prime. And then almost done. We need to divide 6x minus 4y from both sides. So y prime is going to equal this big fraction. I think we can simplify it. You can factor out a 2 from the top and the bottom. So the 2 in the top and the 2 in the bottom will cancel each other out. So that's a simplified version. Okay, so that's y prime. All right, I don't want to have to copy that down again. So let's move that up. Okay, now we need to find the second derivative. So this one is set up using the quotient rule, right? This is like our numerator and our denominator. We'll let f of x be the numerator. And we know with the quotient rule, we're going to need to know the derivative of f with respect to x. So going term by term, that's -1. And then the derivative here is -3 times y prime. Okay, because the 1 comes down, gets reduced to 0. So y to the 0 is 1. But the derivative of the innermost function there of y is y prime with respect to x. Do the same thing for the bottom. G of x is 3x minus 2y. So if we want g prime, differentiate term by term. And so now we can plug everything into the quotient rule. The quotient rule says it's the derivative of f of x times g of x minus the original f of x times the derivative of g of x. And that's all over the original g of x squared. So let's clean that up a little bit, because eventually what we're going to do is we're going to plug in this for y prime to further solve for y prime, for second derivative. So if we distribute, multiply these, it's -3x plus 2y minus 9xy prime plus 6y prime. And so I multiply those two together. I got to watch this minus sign because that's got to distribute to whatever this result is. That's -3x plus 2xy prime minus 9y plus 6y prime. That's all over 3x minus 2y squared. So you got a minus sign in front of parentheses. You can distribute that. And I'm going to just say ditto. Same thing in the denominator. What can we combine? Oh boy. Oh, 6y prime minus 6y prime. That's nice. That's gone. I don't know. Let's just take care. Oh, minus 3x and positive 3x. Look at that. What luck. And then 2y plus 9y makes 11y. So I took care of those. Negative 9xy prime minus 2xy prime. That makes negative 11xy prime. Yeah, that's way easier. Okay, that's all over 3x minus 2y squared. Okay, now we'll plug in this negative x. I'm just going to copy that. Just so I have something to look at. So I'm plugging in negative x minus 3y over 3x minus 2y in for y prime. Okay. Now, it might look hopeless because you're like, I got fractions on top of fractions, but check it out like this. So here's the numerator. Here's my denominator. And so what I'm doing is I'm dividing it by this part, right? So I just rewrote it, just unstack the fraction. But instead of dividing, right, I can flip and multiply. I can make this over 1, and then I'd flip and multiply that part. So this could be, all this is over 1. So I rewrote algebraically, right? Instead of dividing by 3x minus 2y squared, I'm multiplying by 1 over 3x minus 2y squared. Because these can combine nicely to make another higher power. And while we're at it here, put this 11x over 1, and we can multiply that to the numerator. We got this 11y hanging out over here. Oh, actually, if we're going to do this method, the whole thing has got to be multiplied, not just this term, right? So over here, I'm going to multiply these two. That gives me 11y over 3x minus 2y squared. And then when you distribute the x up top, the negative 11x, I'm going to make that positive now because negative 11x times negative x makes 11x squared. Negative 11x times negative 3y makes positive 33xy. And then in the denominator, multiplying this times this, it's just been bumped up a power because it's the same number, just a crazy parentheses. And so you can get common denominators. Clear some room on the whiteboard. Doesn't happen too often. We're going to go back to the top. So when you get common denominators by multiplying the top and the bottom by 3x minus 2y. So on the top, if I distribute that 11y, that's 33xy minus 22y squared over 3x minus 2y squared. Oh, sorry, cubed now because we multiplied the bottom. And now they have common denominators, so we can just add the numerators. These denominators are the same, so we can add the two numerators. I missed this. You can combine these to make 66. You can factor out an 11 from everything. So this is 11, And this is 66xy when we combine those, that makes 6xy. And this is minus 2y squared and plus x squared all over, and it's cramping up. It's a big problem. Okay, I think we're all done now.